The balance thing. Okay. How about you folks? How much you got in terms of the recall in the model? 89 recall.
How it can be?
No, I mean seriously, Pranesh, you got 89. You want to talk about how you've done it? No, I mean that's okay. I mean it might be. I mean, so I'm not like doubting it, but I just want to know what were the tricks that you actually did. You want to share your work very quickly? And folks online, what was the highest recall did anyone get in the last assignment? I hope you can hear me. Manjunath, Bhavna, Kapil, others, Vinesh.
Yes, sir, we can hear you.
Yeah, how much was the recall, Kapil, after the optimization for you? Or anyone else?
Give me a moment, sir. I'm just checking it.
Yeah, please, yeah.
I got what 0.54.
34%, okay. Got it, yeah.
Yeah,
And
54.
how much was your original one, Manjunath?
Uh, precision is 0.87 for 0 and recall is 0.54. Total F1 score is 0.67.
Okay. Recall is 0.55 you're saying, right?
Yeah, 54.
Okay, got it. So everybody seems to be having good recall value now. Pranesh has 89. Is that correct, Pranesh?
That might be precision value, I think.
Might be, yeah. So I mean, but let's just have Pranesh confirm it. In the meantime, folks, what we're gonna do is we will begin with a brand new topic for today, which is decision tree. So if you haven't done the pre-read, I'll give you maybe quick 5 minutes to go through the article number 33, sorry, 32 and 33. If you can just take maybe 5 to 10 minutes, 32 and 33. We'll begin with the a general conceptual discussion of what is a decision tree. Then we will begin with the hands-on exercise on this small data iris, and then we will replicate this on Titanic. And in the later part of the day today, you'll do the same assignment on decision tree and random forest, and see whether you can able to improve the performance better. Right. So that's the plan.
Hello, sir. Manjunath here.
Yeah, Manjunath.
Yeah, I'll be little on and off in the class because I am outside in a hospital.
Oh,
So some
I hope
appointment.
everything is okay.
Everything is okay. Main actually my daughter is not well, so today discharging. So I'll
Okay,
be on and off. So probably assignment late night I may submit.
no
Not
problem,
sure.
no
Like
problem.
if I'm
Yeah,
there,
yeah,
I'll submit, but it'll take little time.
yeah, no problem.
Okay, sir.
Thanks for letting me know.
Yeah, yeah. Thank you, sir.
So article number 32 and 33, folks, if you can go through it very quickly, that'll be great. 32 and 33. Sorry? Cleaning will be there, but probably less than what you have for the linear and the logistic, right? So because it doesn't assume any sort of specific relationship, and we'll talk about those things. Yeah, it's more robust, but there are shortcomings as well. Folks online, if you are done, let me know. And if anyone would like to share their thoughts on what is a decision tree, what are the unique things that you understood, how is it different from what you have learned so far? Anyone in the class? Or are you still going to?
Hello, sir. Manjunath.
Yeah, Manjunath.
Yeah, I went through both about like classifier and regression.
Uh-huh.
So one thing is decision tree is more readable. By directly seeing the graph, we can understand which feature where to split. We can finally write it in like small rules also based on that.
Okay.
Yeah,
All right.
so more explainable in that sense compared to linear or logistic regression.
Yeah.
Their coefficients we need to understand. Here it is more of a split, and each and also the depth, how much the tree can grow and all can be given.
Okay. All right. Thank you, Manjunath. Yeah. I think you've
And
covered some of the things.
in
Yeah.
classifier, it is like Gini index, like entropy is used, and in regression, it is mean squared error is used.
Okay.
Yeah.
Awesome. Yeah. Okay. Yeah. Thank you, Tanmay. Do you have any thoughts or same things? Same? Pranesh, do you have any thoughts? Okay. Rashmi ma'am, any thoughts from your side? Smaller and smaller things, and linear regression will? No, linear regression doesn't do the division of the groups. I mean, grouping will only happen when you're doing a classification. So it's more about a regression problem. So, but yeah, carry on. Any other thoughts? You can bring in. You guys are the real kings and queens of this world, man. Chai and everything coming in. Nice.
No, it is only happening because you are the mentor.
So I think it's almost there, but we'll talk about some of the other aspects. Yeah. Decision tree, regression. So, regression doesn't do it. So it's more about the decision boundaries, which is more the sphere of classification models, right? So I'll just talk about some of the salient features. And if you look into the link that I've shared with you, which article number is that? Probably I should begin with the article number because I myself get confused when I look at the actual article. 32, right? So it says if you don't know what is a decision tree, click on this link. So it will open up a Quora page, right? So this is something which I wrote very long time, 4 years back. So you can see slightly dated information, but the technique doesn't change overnight, right? So what is a decision tree? It's a graph-like model, right, where you're making the decision in a graphical fashion, and you have many different possible consequences, and so on and so forth. But it's very simple visual way. So this is how a decision tree looks like in R. This is something which I generated in R, but we're going to do that same thing in Python, right? Now, why is it called a tree?
Based on the relation, end up at one thing and then how to further divide it or make it. You keep on breaking it into further columns until the last term that you have got is no.
Yeah. Screen is not visible. Sorry, hold on, folks. I mean, my bad. I'll just share the screen. Yeah, I totally forgot about the screen sharing part. Yeah, now can you see it? Yeah, sorry, Tanmoy and Tejashwi. Exactly right. Correct. Both you and Tejashwi got it correct. So it's basically you begin with inverse of a tree, upside down tree, not like a mint tree which is growing like this, but the upside down tree, right? So you have the root and then you have the branches. So one root gives birth to two branches. Then again, this decision node gives birth to other branches, right? And those branches will keep on going in many different ways. But the key thing that you have to keep in mind is it's always a binary division of the branches. So you will never see more than two division in the techniques that you're looking at, right? So, I mean, if somebody says, can you split a node in four? You could do it using some other techniques, but not in the algorithm that we're going to look at today, right? So it's always a binary division, and but this division can keep on going, and the tree can really become very dense, right? People waiting in lobby. Let's see who's waiting. Zarar is here. Yeah, all of those are there. So we'll talk about some of the other aspects as well, right? So let's go like line by line in terms of what are the benefits, right? So these are some of the pros, right? Very easy to build, very easy to interpret. When we say very easy to build, it's not like it's going to build by itself, right? But I mean, you don't have to be like, doing that level of data cleaning and all of those things, outlier treatments. It's more robust to those things, right? I mean, so it's more more robust technique that we're looking at. And more robust to missing values and outliers. It can handle both numerical and categorical dependent and independent variables. So what does it really mean? It can handle both numerical and categorical DV and IVs. What does it really?
Generally, in the previous version, haven't seen a model which handles both kinds. That or either this.
Yeah.
It can be both.
Exactly right. Yeah. So it can be used for both classification and regression. So then how would it know whether I'm going to do the classification or regression? How would the decision tree know that you're expecting me to build a classification or a regression model?
Or probably by the choose of the model. Or you might
Exactly. Correct. Yeah. So instead of, yeah, so you'll say decision tree classifier, then it will know that you want me to build a classification. If you say decision tree regressor, then it will say that you want me to build a regression model, right? So based on that, it can basically do both activities for you. So you can see this is a go-to tool for a lot of different purposes, very intuitive, very simple, much more robust, can be used for both classification and regression. So it has natural benefits which actually make it more suitable, choice of the algorithm compared to a linear and logistic, right? But we're not done yet. So we can continue to go on. It is more white box. White box and black box, do you understand? Exactly right. Yeah. Yeah. So here it's much more visual. It will tell you exactly this is how I split it for you, right? And whether you agree or not, I mean, this is the best choice. And it is non-parametric. A very, very important point. Non-parametric.
Yes. So there is no model algorithm that is coming out from the.
Right. Yeah. So very, very important point. And this is what makes the decision tree much more robust to some of the things that you looked into. So let me just see if I can quickly bring up my Excel file here.
The non-parameter or the
No, no, no.
concept of parameter.
No, two different things. So this is non-parametric in terms of not assuming a particular relationship, right? So anytime I connect my HDMI, I cannot write. So I'm just going to draw some basic things, right? So it's not going to be like super neat drawing. And I'm not doing it on the board for the benefit of the people who are there online, right? So even the click is not working. I don't know why it happens actually. Is it the mouse thing? I don't know why. Just like weird. Anyway, so let's just look into this, right? So pardon my drawing if you don't see anything. You may think like I'm drawing, but it's not coming on board, right? So this is X, this is Y. So the linear regression says the X and Y should be like this. Yeah. So if you have a relationship like this, for example, let's choose a different color, like this, right? So does it mean X and Y are not related?
No,
They're related, but they're not linearly related, right? So this will be a good choice. This type of relationship will be a good choice for linear model because you're assuming a linear relationship, right? And the one that I'm looking at in black is, a good choice for tree. And this is also a good choice for tree because tree works for all sort of relationship. As long as there is any relationship between the X and Y's, tree will be say, okay, fine, I can give you what is the best possible spread. Right? So it's not assuming a particular relation between the X and Y. As long as they're related, tree is good to go. However, linear regression model, logistic regression models, they get into mental block, so to say, that I'm assuming a particular relations, right? And if those relations are not there, then they're not going to be very effective. So you'll see that suboptimal precision recall, suboptimal square errors and stuff like that will come in because of that particular issue, right? So that's what I mean by non-parametric. So it is very, very robust for any sort of relationship, right? And I have, simplified the relation. I mean, the relations could be even more complex, right? So I'll just draw slightly more tricky ones over here. So let's say for a particular period, it goes higher, then it becomes flat, and then it comes down, and then again it goes higher. Something like this. I mean, it might happen, right? Decision tree will work even in this case as well. That, I mean, I'm not assuming that you have a unimodal or bimodal or any sort of like fixed relationship. As long as they are related, I can be able to give you that particular split, right? So any of the relationship at any point of time, it will be able to pick it up. That's the main point, yeah? So these are some of the benefits, right? So let's talk about some of the shortcomings. It's not like, I mean, everything is hunky-dory over here. They have a problem of overfitting, right? So they actually learn too much data. What is the overfitting? Let's just begin there as well. What is overfitting, underfitting, right fitting?
Overfitting is if you do not analyze and they don't have better. I think do not make it enough. Might be really you find the pattern and give the better when it comes to the new data.
Exactly right. So overfitting meaning the model that you've built does a phenomenal job on the training data. But the moment you take that model and put it on the test data, the model performance deteriorates, right? So let's say you get a fantastic precision of 80% on the training data. The moment you take that model and put it on your test data, you may not get 80%, you may get 60% in terms of the precision and the recall, right? So that means there's a degradation happening. Now, how do we define the degradation? What exactly is significant or not significant? I'm not going to go there. But you can see there is like, a big jump in terms of the model performance in the training versus the test, right? And to your point, Tanmay, that if I take it and apply that on unseen data, then it may be even worse because that data may have some other peculiarities which are not there in my training data that we're looking at. So that's the basically challenge with respect to the overfitting. So overfitting meaning that it's like a one-trick pony, right? Or I mean, you know that only one thing you can do, right? But you cannot do many things, right? So I mean, there's a benefit in having that, and there are flip sides to having that as well, right? So you should be something that you are more generalizable. The model should be more generalizable because it's not tailor-made for one specific data. You're going to use that model in real world, right? Real world data is messy. You'll have nuances coming in. So all of those things need to be figured in terms of fitting that model. That's the main point behind that, right? It is very unstable as well. What does it mean by instability? If you read the second line, correct. That's correct. That's correct. So if there is any change in the underlying data, the one that you've trained on, there is a new set of information that comes in, right? You may throw in a couple of other variables, right? So the entire look and feel of the tree may go haywire, right? So you say, okay, just yesterday you're looking like this, and today I gave you this data and you're looking completely different. You gave me new data. What do? Right? So it's gonna, eh? I'm talking to the decision tree. No, that is also there. So I must compliment you. This is I mean, I like this. I mean, so I thought maybe just me thinking, but you confirm that view. So the third point is it may be doing a favor to the variables which have higher range or more levels, right? So if I'm looking at a categorical variable which has 15 different values versus a categorical variable which has 2 values, it may favor more the one which has 15 values, right? Similarly, for the regression point, it will say, okay, let me look at your range, right? And I will go heavy on people who have a bigger range, right? So those are just the shortcomings in terms of how it works, right? Generally less preferred over more robust statistical techniques when higher precision and recall is desired, right? So it may give you a good fit, but if you're trying to optimize the performance, it may not give you both of them together. So that's where, some of the other techniques like ensemble model, which we're going to talk about today, like a random forest will come in, right? Which will do all of that, right? There are many, many different techniques. I mean, and many different algorithms, which all work something like in a similar way. There are some main ones like a CHAID, which is the chi-square automatic interaction detector, CHAID, right? So R provides this algorithm. Python does not have a CHAID. CHAID works on the concepts of the contingency table. So if you've gone through in the statistics class, like, I mean, it will do a chi-square test, right? All of that. So I'm not going to go there. We're going to focus on the algorithm called as CART, which is classification and regression tree, right? So it's the name itself says that I'm going to do both for you, right? So classification and regression tree. There are others like ID3, Quest, and all of that. Depending on the tool that you're using, they may have a particular version, but we're going to look into this, right? So how does CART really work? And Tanmoy, you talked about the concept of impurity. Can you highlight what is an impurity?
Give me intuition. So think about one tree or one box. We have two types of models. One tree, one box. So if you then just so it is pure, purely impure.
Purely impure. Wow. Okay, nice. Yeah. Yeah.
And now I just segregated those things and came to the one box where it's just 70% of the
Yeah.
so now in that box it's more purer compared to the
Absolutely right. Yeah. So for the folks online who couldn't hear Tanmoy, I'll just try to talk about what we are looking at. So just give me a moment. Right. So the purity is, let's say, building on what you were talking about. So let's say I have a box, Tanmoy, right? And in this box, I have two different types of marbles, right? So this is green marbles, which are 50 pieces. And then I have pink marble, which are 50 pieces. So both are equally represented. It's a very, very diverse group. But for a decision tree, this is the most impure system that you could have, because you have the full representation or the equal representation from both populations. So this is the highest impurity for a decision tree. Why? Because it's trying to separate out the pink from the green ones, right? So let's say whatever decision tree does, and after that it creates two different buckets, and in this bucket all we have is the green marbles, and here all we have is the pink marble. This is what the tree will call as the purest, and that's what it's trying to accomplish, to give you the segregation between the classes that you have. Let's say when you're looking at the Titanic data, you had certain number of survivals, certain number of non-survivals. So there's going to be certain level of impurity. Decision tree will work its way through to separate the survivals from the non-survivals completely, so that you have one node which is purest in terms of the survival, the other node which is giving you non-survival. And that is the whole purpose of building a classification model, because you'd like to tell the fraudster from the non-fraudsters, defaulter from the non-defaulter, and so on and so forth. That's what the tree tries to do, right? How does it do it? There are techniques, there is a concept of Gini and impurity, right? So, sorry, Gini and entropy, right? So there are two metrics, and we can see it works on both of them. And I'll just quickly pop up the formula for over here. These are the metrics of the impurity, right? So if I quickly go to the Google and say Gini decision tree, right? Click on the images. I don't have it in my blog, but you can definitely find the formula very, very easily. I should update that, right? So here it is, right? So this is the formula differences. So Gini is 1 minus probability squares. summation of probability squares. Entropy is nothing but probability of each event to be happening times the natural log of that event, and summation of that and negative sign, right? So let's just copy this image and bring it in the Excel, and I'll just walk you through one example. And again, these are some of the things you don't have to do by hand. The tree will take care of it for you, but something you must definitely be familiar with, right? So Gini is in, like I said, I mean, is a measure of impurity, and it's defined in this way. Similarly, the entropy, right? So let's say, let's do one example, right? There's a class, right? Let's say I'm looking at a physics class for class 10th, right? In that physics class, there are 15 boys and 15 girls in the class of 30, right? Let's try to define the entropy. Right? So what is going to be the entropy? Entropy is nothing but negative of first probability. What is the probability you will have a boy? 0.5 or 15 by 30 times the log of the same number, which is 15 by 30 on the base of 2. Right? What is the probability going to have a girl? Same. So I'm just going to multiply that by 2. And your entropy comes out to be 1. So that means if you have the highest impure system, the entropy max value will be 1. Right? Now let's imagine another class where we have 30 boys, or let's do 29 because then natural log will struggle, right? So 29 boys and 1 girl. What is going to be the entropy of that system? Let's do the same math, which is the probability of finding a boy, which is 29 by 30. 29 by 30 times the log of 29 by 30 on the base of 2, and I'm adding up the probability if you look at that formula. So what is the probability of finding a girl? 1 by 30 times the log of 1 by 30, right, on the base of 2. Correct? Is that correct? 29, 30, 29, 30, 130, 130 on the base of 2. So you can see the probability, the entropy there is 0.21. So if the system is purest, then the probability, the entropy value will go lower. So the entropy will go down to as low as 0, actually, right? So there is a possibility that you can have a 0 entropy as well. So the max entropy of 1 suggests that the system is highest impure. I'm talking about the binary classification. If you have a tertiary or more, then you'll have a different formula. But I mean, formula will remain the same, but different number that will come out, right? But for a binary, the entropy max can be 1. Same way as Gini. So who would like to tell me the Gini? What is going to be Gini for system 1 and system 2? So let's say this is system 1. Just expand on the formula. You can do the calculation in your own system. System 1 is this, and system 2 is this. So let's say system 1 is co-ed, system 2 is all boys college, but one girl happened to be there because she was the daughter of vice chancellor or something. Right? So what is going to be the Gini based on this formula? So this is the max value for this system, and this is the lowest value for this system. I mean, based on the mix. Close enough, but not quite. Yeah, you're doing the mental math, so you can just do the system also. You will tell that, yeah, I think you're right. I mean, the formula that you walked me through, that's correct. But somewhere your arithmetic did not work out. So let's do 1, right? So what is going to be the Gini for system 1? I'm just going to define the Gini. And Gini is nothing but 1 minus probability of first event to be happening, which is 15 by 30, and square it, right? If I look at this formula, I'm looking at this formula, right? 1 minus probability of first event to be happening, which is the probability of finding a boy, and that is 15 by 30 square, minus probability of second event to be happening, which is again 15 by 30 to the power 2. And I need to put an equal sign. 0.5. So the same place where entropy was maxing out to be 1, Gini will max out to be 0.5. Right? Now, who can tell me the system 2 Gini, what it's going to be? Just follow the same math. It will be difficult to do in your mind. Better to do it in system. Let me know what exactly that comes out to be. Point 0.06. Makes sense? How many of you agree, disagree? Anyone online who has a result? Then I will ask you the next quiz question. You have to do the same thing for iris data. Both entropy and Gini. I will also go your way sometime.
After 2 years, you will have no yet. We know here.
That's the state of nirvana. Yeah. My company CEO is, I mean, the richest person, or was the richest person, right? I mean, but he never thought about doing anything with the hair. So, yeah, do we have the answer? So you are saying 0.6, Pranesh.
I have got
Yeah, Bhavana, speak louder, please.
yeah, I've got 0.06.
0.06. 0.06. Gini?
Yes.
Okay,
Yeah.
sorry. Yeah, you're right. So 0.06, correct. Yeah. Because I was thinking the other way. Yeah. Yeah. 0.06 is, you also got 0.06. Bhavana got 0.06. Anyone who doesn't agree or agrees, or you don't care? Either way. Okay, so 0.06 it is, right? So let's just go with this, right? So you can see like the lowest, so when the system is impure, the Gini will be max at 0.5, then it will trend towards the 0, right? So that's one big takeaway that you can take. And I think there might be a chart which I can directly pull up for you, right? So the max value of Gini and the Gini decision tree max value binary. So I think I can directly leverage that chart if it is available somewhere. If not, then I'll definitely do it. So you can see this is how the the Gini looks like, right? So it may, go. So when your probabilities for any event to be happening between 0 and 1, the Gini max out at 0.5. So when the probability of both of the binary will be 50-50, right? So when one class overshadows the other class completely, let's say you have all boys, No girls, Gini will be 0. All girls, no boys, sorry, all boys, no girls. I mean, you can again 0, right? So I mean, if it is like either one of the classes completely overshadowing the other class, then Gini will trend towards 0. When it is equal, then the Gini will max out at 0.5, right? So that's the main thing. Similar chart is there for entropy, but the scale will be not 0.5, the scale will be 1. So it just max out at the slightly higher. That's the only difference, right? Now the quiz question. Let's see who's the fastest one to give me the answer. We're gonna do that in the Python as well. So iris data, how many flowers are there? 3 flowers, right? So what are the names? Yeah, so Setosa, Virginica. You get the idea, right? And then the third one is the Varsicolor. How many of those are there? 50, 50, 50, right? So is this the purest system or the impurest system? What do we think? Is it the purest or the impurest? Impurest, highest amount of impurity, because there are 3 classes and they're all equal. I mean, it's a good diversity thing, because diversity, equity, and inclusion, it's all good. Like, I mean, you are equal representative, right? But in decision tree's mind, it says, okay, this is the highest impurity. I must do something about that to separate the flowers. That's what it's going to do. So the quiz question for you is compute the Gini and entropy for this system. What is going to be the Gini and entropy for this system? I'll pop up the formula again if you want to see that, but you get the 50, 50, 50, each one of them. So my question is, what is Gini, what is entropy for this system? Gini is 0.33, okay. So in this one, let me just write down. So Gini is 0.33, Tanmoy says. What about entropy? Gini is 0.6. Okay, so I'm getting like.
So it is 1 minus, so that way it is maximum is 0.5.
No, that's only for binary.
So only for
0.66, okay. That is only for binary. That's why I'm actually giving you this, so you don't get married to that idea. 0.5 is and 1 is the max, right? 0.66, okay. Then entropy.
Ginny cannot be more than 0.5.
0.5 only for the binary. For the tertiary or multinomial, it can be higher.
Okay. No, the formula says 1 minus, right?
Yeah.
So
So what we're gonna
anything
do?
1 minus should be less than 1.
So let's do that. So
Okay,
let
okay. Sorry, sorry. I got it. Sorry.
yeah. So
I
1
got it.
minus 50 divided by 150, right? Because that's the Setosa or Versicolor Virginica times 2. And because I'm going to do the same thing 3 times, I can use my multiplication. Rather than adding 3 times, I can do multiply by 3. And that will give me, if I only put the equal sign, give the answer, which is 0.6667. No entropy. Anyone? Ranesh, you have the answer? Hmm? 1.4? Well, anyone online has an answer? It's very straightforward math, just like what we've done. 1 minus P, let's define the P, which is, okay, yeah. Let's just do it one more time. 1 minus probability of the first event, which is 50 divided by 150 times the natural log of the same event, which is 50 divided by 150 on the base of 2. And then I have 3 different events. So I can do minus 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 3 times, or I can simply do times 3. And what is this? Sorry.
It is not 1 minus.
Yeah, my bad, my bad. Now, even the format is messed up as well. So minus, and then do that, and then I need to make it number. 1.58. So it can be higher than 1. For binary only, it's 1. So this was saying that, I mean, so you can see the trend is the same way. For binary, the Gini peaked at 0.5. Now it's peaking at 0.66. For binary, the entropy peaked at 1. Now it's peaking at 1.58. Right. For binary only, it's the one that you should remember, right? So now let's shift gears. Sorry, before I shift gears, I don't want to brush it aside. Any questions, thoughts, folks, from anyone? Is the concept clear? Overall decision tree, how it works? We're gonna see in the motion now, in action now. But anything which is not clear to you, based on what you just heard from me and in the previous classes? No meaning all clear, no meaning nothing is clear. No doubts, okay. Yeah. Okay, so we are good. Yeah. Which one? EN. Huh. AK. Huh. I got it. Akinator. What do we do now? Click on it.
So now,
Yeah.
so it's the same system. So just play. Now, you think about okay, some person or some initial base attack. Before we are talking about now it's a test. Indian.
No.
Absolutely. Yes.
K-on. I don't know. I don't watch these things. I'm slightly. Probably. How many legs?
No.
I think I went on a different. Let's just try what comes out. There might be something funny. Wow. Finally, something. Oh, nothing comes up. Yeah. No, maybe I have taken it in a loop where it's. You want to select first, say one more time?
Just think, okay.
Huh. Animal?
Do it with animals.
Animal. Let's try animal. How many legs? No. ये तो बहुत obvious हो गया ना. Which animal has 3 legs? There are animal with 3 legs?
Okay, thought provoking, no. Maybe I should be.
Does yeah, sure, okay. 3 leg तो auto ही होता है. Can any animal be found in pet stores? Yes.
Yeah, no.
Yeah, let's say yes. Let's say if it is a no. Okay, so maybe the tool doesn't like me. It just keeps on asking me the questions. I mean, I was thinking like cat.
Yeah.
It's a pet, can be found in a pet store, has 4 legs, doesn't bark.
No, it is not predicted to be a cat.
Okay, we'll go back to the iris.
Okay.
Yeah?
Now I got to understand.
No, but good try. So we're gonna do, folks, this iris decision tree, and what we're gonna do is we'll try to separate out the flowers, right? So this is gonna be hands-on exercise. So let's go ahead and switch on. I heavily recommend that you do it in the Google Colab. Otherwise, it won't work for you because there are certain graphical packages which you will have to install in the local version. So fire up the Google Colab. So the first thing you want to do is install GraphViz, which is the way to visualize the decision tree. Then, so after you've installed the GraphViz, import it, load up your data from sklearn.datasets import load iris. And then this is the model that we're going to try out from sklearn import tree. Till this stage, till line number 4, everyone is good? Ranesh, all good? Rashmi? Okay. Folks online? Okay, I take it as a yes. Then you're gonna do the NumPy and pandas. Yeah. You will load your data, which is iris. Right? Create that instant, and then you're gonna build a decision tree classifier. Why a classifier? Because we're doing a classification. We have three different classes, Setosa, Versicolor, and Virginica. We are doing the classes, and that's why it's a classification. You're gonna do a regression exercise as well for your comfort. And then criteria I am passing on as an entropy. The same thing that we've talked about. So you have to tell the decision tree what impurity criteria you are using. So I'm using entropy as a criteria. Yeah. And it's slightly, the order is slightly messed up. So print should come earlier, but that's fine. So I'm going to rerun this one. And let me know till line 7 if you're with me. Yeah. Okay. So you can skip line number 8. Pranesh, you're good. Line number 8, we're gonna skip. We don't need that. And then this is where we're gonna fit the model. CLF.fit, iris.data, iris.target. Can anyone tell me what exactly we're doing here?
Fitting those target.
I'm passing on the X and Y array.
Yeah.
Iris.data is the X, which is the petal length, sepal width, all those parameters. And iris.target is the Y variable that you're looking at, right? So that's all we are telling, that this is your X array, this is your Y array. Please learn the behavior between the X and Y. And we're doing it for the entire data. We're not splitting and all of that because we're just going to visualize the tree. So we're going to do the entire data. Iris.data, all 150 rows come in, and 4 columns, which is the petal length, length, sepal width, iris.target, all 150 variables come in. So you can see the shape also coming up, 150 rows with the dependent variable. Yeah. And then you will type out this line, which is slightly busy. So I will explain that in the next line, which is the line number, line number 16. So 15 and 16, if you can just finish. Yeah. CLF is the object that we created earlier on, which is the classification object. Then we fitted, or basically the instant, which is a more appropriate name. So we've created the instant called CLF, which is nothing but a decision tree classifier, which takes entropy as an impurity measure. Then we're going to fit on the entire data. And then what we are moving on to is the visualization of the tree. So we are creating an object called dot data, which is gonna work on the method called export graph viz of the tree. We are passing on the classifier. Out file is none. I don't want any out file. Yeah, go ahead. Is there a question, folks? Okay.
Sir, can you scroll up a little bit? I
Which
think
which
I'm
one?
getting error with tree.
Which one, Bhavna? Where?
Fourth line.
Just line 9, yeah?
Fourth line.
49?
Fourth.
Fourth line.
You need to from sklearn import tree.
Okay. I didn't do this.
Okay. Okay, so then we are here. Sorry, we have to move up and down a little bit. Yeah. Got it? You have the tree also? Nice. Yeah, exactly the same thing. Yeah. Okay, so anyone who would like to tell me what we are doing in this code? I mean, I think everything else till now should be very obvious, but I'm just gonna recap that. So this is the tree plotting library, GraphViz. We're gonna first install it, then import it. We will load our data, which is the iris data. We will import this instant, which is the tree. So whether you're gonna do random forest or decision tree, you're gonna import that tree. And random forest may be a different package, but tree is basically follow all of those things, right? Numpys and pandas as the usual suspects. We're gonna create this data iris. Then this is very important. So within the tree, you will have decision tree classifier and regressor both. The reason why we're doing a classifier, because it's a classification activity. Iris, setosa, versicolor, they're not continuous variables, they're categorical variables, right? Criteria I'm just choosing as entropy, right? And I'll show you the Gini as well, so it won't look any different, hopefully. Then I will move on. Then we are fitting this on the entire data. Iris.target has the Y variable, iris.data has the X variable. And then we are doing the visualization of that. So we are doing the dot underscore data, which is the object that is gonna store the picture, the graph of that. Tree dot export graph is name of the classifier, and you do the exercise on Titanic without my help. So just make sure that you're paying attention. You will pass on the name of the classifier, which is the Titanic. Out file is none. I don't want any out file to be generated. If you want an out file to be generated, you can give a format, but not necessarily required. Features names is the same as your X variable names, right? So it's gonna basically label the tree for it. Class names is nothing but your target names. So Setosa, Versicolor, Virginica that you had there. Filled meaning you want to have the color coding. So all the boxes should be filled. If you don't have the filled, then they will be white, all white. Rounded meaning you want to round out the number to the nearest places, and there are, of course, I mean, other things that you can play out. Special characters, if there are any, that's fine as well. So then we're gonna do in the next line, which is the graph. You're gonna do the graph using graphviz dot source and dot data is the file that we've created earlier on, or the object that we've created earlier on, right? We're just plotting that tree, and I'll zoom out a little bit, otherwise you won't be able to see. There you go, right? So I'm just doing the dot data that we've created earlier on. I'm doing the visualization of that, and I'm displaying the graph. And this is how the tree looks like. Now, what you find as a very interesting thing over here is that it has three different colors, right? Everybody sees three different colors: orange, green, and purple. So what are the color coding over here? Just see the color coding and tell me what do you think you can make out from over here. Right. So it is assigning different colors to different flowers. Why the root node is white? Because 50-50-50. So it is neutral. Not you're not orange, or yeah, I think that's orange only. No, peach color. You're not peach, you're not green, you're not blue. Because I have all flowers as equal. So that's why it's all white, right? In this one, why is it all white? Equal, right? So again, impurities at the highest. When the impurities at the highest, the color is the white, right? So you can see 50-50 out of total 100, and I have the entropy of 1. If you remember, we just did this math earlier on. For a binary class, the entropy will be 1. So it's basically the highest impurity that you can imagine, and that's why it's a white. Now, why is this guy all orange? And yeah, only one species is there, right? Which is Setosa, and entropy is 0. So you can see this is the concept of the impurity minimization, right? I mean, it's trying to minimize the impurity going down the path so that it can basically figure out what is going to be the purest node. And then you can go on, it's going to be a blend of the colors, right? So I'm not like, the expert in the color and all of that, but it's going to be a blend of the color depending on how pure or impure your system is, right? So this is how the entire tree looks like, right? So let's look into the top of the node. What all can you read from this? Top of the node. Yeah, so total sample size is 150. That's correct, Tejashni. What else? Yeah. So 50-50-50. Here it is saying class as a Setosa. So basically it's saying I'm building a model to predict the Setosa for you. Right. But even if it is building a model to predict the Setosa, it's going to automatically do the prediction for Versicolor and Virginica as well, right? What else do you notice?
So here the first thing is how it is bifurcated.
Exactly right. Correct. So it is saying the first criteria which will help you separate the flower is the petal length. And if the petal length is less than or equal to 2.45, you will be on the left side of the branch, my left. So I don't know whether it's your left also. Is it your left also? Yeah. So, so right. So it is the left side. If it is less than or equal to 2.45, then you're on the left side. That means it's true. So if the flower has less than or equal to 2.45 petal length, all of those flowers will be what? All of those flowers will be Setosa. So it gave you a very quick decision rule that if I'm less than or equal to 2.45 in the petal length, then I am a Setosa flower, right? So it's a very simple rule that it has given you right away. Huh? Huh? But it won't be the same variable then. You'll be looking at the petal width or something. Yeah, so that's something decision trees are unstable. So depending on how I do versus, but if you do a correlation between the petal length and the petal width, they'll be like 100% correlated. So it's basically saying, okay, I just, yeah, I randomize somewhere. And in my model, I'm using petal length, and your model, it's using petal width, right? So up to a certain extent, because these are very heavily correlated variables, right? So that's why it's basically saying I can pick either a petal width or petal length. Basically, they're both measuring the size of the flower. So if the length of the flower is lower, the width of that petal will be also lower, right? So basically, what it's trying to say intuitively is the smallest size of the flower will be Setosa, whether you look into the petal length or petal width, right? So I don't know. I mean, so you can say the height in inches versus the height in centimeter, right? So they are very correlated, 100% correlated, right? In this case, petal length versus the petal width is also very correlated. So your model may pick up that variable versus something else. But if they're not correlated, it will automatically pick the right variable for you. Or I mean, the variable which will be same for all of us. Yeah.
Yeah.
because it may have randomized somewhere else. So if you want to replicate exactly the same output, let's try this thing. Yeah, let's try. I don't know whether it's going to work or not, but let's try it out. Yeah, in the classifier that we're going to build, random state is equal to 23. Let's all of us try with 23. Everyone 23. Why 23? No particular reasons. Yeah. So don't know what is the output yet. I don't know whether I've done it or not. So let's see. Slightly difficult to move up and down. So this is done. Okay, fine. Why don't I just run the entire thing and be done with this, right? So rather than going one by one. So I'm just gonna run the entire thing one more time. There we go. So now petal width I'm getting. How about you? Everybody's getting the petal width? Right? Yeah. So that's what it is, right? So it's so with the 23 as a random seed, everybody is getting the same output, right? It doesn't mean that the model that you built with your randomization was superior or inferior to my model. It just means like it picked a different variable because of the randomization it did, right? But if I want to exactly replicate the same output, then I must have the same random seed. Then everybody is going to initialize at the same point and will get the same output, right? Now it's the same interpretation, right? I mean, the interpretation doesn't change. It basically means the smallest flower is a setosa, right? Now let's look at some of these flowers. I mean, we have been talking about iris for like ages now. How does this flower really look like, right? And iris, setosa, versicolor, and virginica. Yeah. So you can see setosa is this guy, versicolor is this guy, virginica is this guy, right? They all look the same, but I'm looking for an image which is on the scale. Maybe this image is on the scale. Now, can you make out any differences? Which one is the smallest one? Setosa is the smallest guy, right? Versicolor is the biggest one, and hopefully the data is going to tell us the same thing. And virginica is somewhere in the middle. I know, I mean, you'll say, okay, well, maybe this flower is just little and it's going to grow up later on, right? So, right? But they naturally are like, you know, the smallest in all of that in terms of the relative size. Let's see, pick up another one. Here, yeah, the difference is not very clear, but you'll see that is naturally the order of things that you're looking at, right? And you can read more about this, right? I mean, in some other articles and some other shape and form. Um, yeah, and these are the dimensions. I think this is a good picturization. Let's pick up this one. Yeah. Three different species for the same one. Yeah. How do I move this bar anywhere else? Can I drag it down? It just stops. Okay, there you go. Where did it go? This is one. This is the one. Yeah. There you go. Right. So that's the sepal length, petal length, petal width concept, right? So you can see that if the width is smaller, the length is going to be smaller, and vice versa, right? So it's not necessarily like, I mean, they are disjointed attributes of the dimensions, right? So naturally, if your length is not that big, then the width is not going to be that big as well. And they're proportional, length and width, and they're heavily correlated as well, right? So if you want to do it, let's try to do it, right? Over here, what is the relationship between the petal length and petal width, right? Or let's do for all of them. So iris dot core. Okay, we haven't converted that into a data frame. That's the reason. So let's create a data frame. Iris underscore df is nothing but pd dot data frame, right? And let's pass on this guy, which is called iris dot data, right? I'm just going to look at the iris dot data, nothing else. And the columns will be nothing but iris dot. Why is it not popping up? Normally it should come in the IntelliSense feature names, right? So, oh, because I have a capital, that's why. Iris dot feature names. Okay, so we have created the data frame. Now we're gonna do iris underscore df dot core. And there you are, right? So let's look into the correlation between the petal length and petal width, 0.96. So they're like one and the same thing. Everybody has the output, right? So that's why it sometime will pick petal length, sometime will pick petal width, because they're both the same dimensions, the same attribute of the data that we're looking at, right? So you shouldn't be surprised, why for somebody else it was PL versus PW, right? Because they're very correlated by looking at that correlation, which is 0.96. Everybody is able to see online, folks?
Yes, sir.
Yeah, okay, cool. So just a quick demonstration, like, the tree that you built may be looking slightly different from somebody else because the variables themselves are interdependent, right? Now, do I need to fix the correlation before I build the tree? Yes or no? Like in a linear regression, multicollinearity. We don't have to do that, right? But then you will have these as the side effects of that you may see petal and somebody else may see petal width, because we haven't fixed the multicollinearity. If you fix the multicollinearity, you will not see these things happening. But decision tree is not hung up on multicollinearity. It says, okay, I don't care. You give me all the data, I'll just give you the best possible output, right? So that's the beauty of the decision tree. So let's continue moving down. So now I'm looking at the petal width. So I hope it doesn't throw off anyone, right? Continue down the path. So what is the left branch and right branch? The left branch says when this criteria is met, right? So if the petal width is less than 0.8, you are on the left branch. And the branch is, or this node, so this is the node, this is a branch, right? So this is the root node because we're starting from there. This is a branch, left branch, right branch. And this is a terminal node. Why is it called a terminal node? There's nothing else to be broken up. So it says, you wanted me to reduce the impurity and I have given you a zero entropy system. It cannot be any purest, right? So that's why I'm actually going to end. It's a terminal node. On this side, it's not a terminal node. So what is the next criteria it is using? Petal width again. Petal width again. So it's saying you're not the smallest guy, but you're also not the biggest guy. So you are more than 0.8 in the petal width, but less than 1.75. I hope this makes sense, right? So it says you're not the smallest, you're not the biggest, you're between 0.8 and 1.75. If that is the criteria, then I come to this decision criteria. So again, this is true, this is false, right? So it's basically applying this criteria on this data, which is 100 flowers. And how many flowers meet this criteria of less than 1.75 but more than 0.8? Anyone who can tell? 54 flowers meet that criteria, right? So 54 flowers will come on this side and 46 flowers will come on this side. So there are 46 flowers which are more than 1.75. A large majority of them are Virginica flowers. Like almost everybody is Virginica only, right? So out of 46 flowers, 45 turn out to be Virginica, right? Because they are the biggest one. Virginica is the biggest one, right? There was one flower which was sort of like, classified as a versicolor, but might be Virginica, right? Because of the size, maybe it's on the boundary and all of that. But then you can see that there are 49 flowers over here which are versicolor, and 5 are Virginica, which is again a confusion slightly. And then it will continue to break it down further and further, right? So then it will come down to this stage where you can see like, this node has 100% versicolor. But what is this node? Let's take a look. If I follow this and try to interpret this node. So of course the petal width is less than 1.75, then petal length it's using as a criteria less than 4.95, then petal width again less than 1.65, and then finally you come to this, right? So it says, okay, if your petal length and petal width happen to be in this range, then you're gonna be a Varsi. Otherwise, it's some other node that you're gonna be on, right? So this is how basically it will come down to that, right? The moment it cannot split further, it becomes a terminal node. But if I let the tree grow like this, the tree will be very, very wild. Like, I mean, it won't be like, good looking tree. It will be very difficult for you to interpret as well. So we're going to do some trimming of the tree as well. So let's do the trimming of the tree, right? Which is the criteria that we're going to use now to figure out what we have to do, right? So we will go back to the classification, or I mean, the classifier instant that we were looking at. Let's go over here. Sorry, not this. Before I do that, I mean, you can try with the Genie as well, so it wouldn't look different. So let's try this first, right? So instead of selecting the entropy, just change it to Genie and rerun the same thing. I will give you a chance to run it and see whether you find anything different. So I'm just going to rerun the entire code, in fact, to be lazy. Oh, I think I'm not connected actually. That's the reason it's delayed. There you go. Yeah, because the graph is not try with different sources, like some other graph. That's the challenge I was talking about. So it's like literally some of the packages they're not there. Yeah. You're doing it in Collab or Collab? Collab will have all the dependencies, but in the typical notebook, we did the suggestion in the Collab. So you're the only one who works. Or if you're against Google. Okay. So, but that's the dependency. I can bet 101% that some packages are not there. You need to update, you need to install some of the things, and that's how basically it is like. So now again, we have done the Genie, and you can see the Genie at the max comes out to be 0.667 Genie, right? So just like what we did in the Excel. So now Genie is speaking at 0.667. Again, you can see when I have a pure system, Genie goes down to 0, right? So some of that confirmation is what we're looking at, right? Now let's look into the pruning of the tree. Like you don't want to have a weird looking tree in your house. Similarly, we don't want to do that over here as well, right? So, and I will show you some of the criteria, folks, right? So let's go. Okay, great question. We will do the hyperparameter optimization in the next class, and I'll talk about that. The bottom line is you don't know. You're gonna try both of them. Okay, so these are the different parameters, right? When we talk about the hyperparameter optimization, that means what are the parameters that a particular model takes. And till now, we haven't gone into territory of the hyperparameter optimization. The only thing we did was in the logistic regression where we say the class is balanced, right? So that's the max we've gone ahead and done it, right? Now, today's a third class or second class? Third class, yeah. So fourth and fifth class will do more on the hyperparameter optimization and figuring out. So it's a 5-class model. So we'll try to wrap up accordingly, right? But these are the parameters which it takes. So the parameter criteria could be Gini or entropy. Splitter, best, random, default, right? I mean, whatever, right? So I'm just gonna go with the best. So there are, when you do not pass on anything, it doesn't mean that it's not taking anything. It's taking the default value of the things, right? So default value is Gini, default is best, max depth is none. So can anyone look at the max depth and tell me what do you think this may mean?
How many number of
Right. So how many different levels you want to go down? So if I say I don't have any criteria, then it will go weird and it will just have many levels, right? And you won't be able to see the tree on the screen as well. Because this is a baby data, you can see it, right? I mean, the moment you go to Titanic, you won't be able to see the tree yet. You'll be looking at one node and you have to scroll like 15 times to see the parent of that, right? And so on and so forth. So it will be just like too much difficult for you to handle, right? So that's what we're trying to specify by max depth. Next one is tricky, min sample split. Look at the description, tell me what do you think this is?
I think sample
Exactly right. So if it is, you split and it comes to a node and it says, okay, shall I split further or not? So it says the minimum sample split is 2. By default, it's 2. So as long as there are 2 members, it will say 1 here, right? But if you say, I want to do min sample split as 50, so that means unless you have a 50 member in that node, it won't be split further. So for example, if a node has 45 members, it says, no, you asked me to only split when you have 50 members, so I'm not going to split that. So I'm just going to leave it alone. So that will become a terminal node. So again, you've cut the tree. How you cut the tree? By saying, okay, I want to have minimum of this before I split further. So that's the second criteria of cutting the tree. First criteria is, huh? Okay, max depth is clear?
Yeah.
Min sample split is like how many members you must have before you divide them again. In the same node, how many members you should have before we divide them further. Because what this tries to ensure is that you're not like splitting something which is non-significant for you, right? So let's say I'm doing a marketing campaign and I'm going to do a targeted marketing for that particular segment. And you say, I must have a minimum of 50,000 people in the segment for me to have a viable strategy of targeting that segment. So unless I have a 50,000, I'm not going to do a customized program for them. So this is the same way for a tree, that don't try to make it more pure. As long as you have this, then you can go ahead and split. But if you don't have that mass, then do not split further.
which one will take
All of them will fight together. So whichever criteria is met first will be the one where the tree stops. So if you say go up to 100 branches, you say go up to 100 level of depth of the tree, but the min sample split is 50. So which one came first? The min sample split will come first. I'm just saying, it will naturally come because you don't have that much data, right? So it will stop there. So even though you have told it to go and get 100 of depths, it won't go there because the min sample split criteria is met, right? So it says I don't have enough mass to distribute and split further, and that's when I'm gonna stop. So these are the early stopping criteria. Any criteria which is met first, the tree will stop there.
data size in that
Tree?
particular
Hmm.
so
I'll show you what is min sample split here. Okay, I have done some weird thing in the criteria, but that's okay. So over here, if I passed on the min sample split as 101, If it would not go further. It will say you asked me to only split when you have at least 101 members. I only have 100, so I'm going to stop here.
Depending on the data set you're importing.
Correct. Now, how do I know what should be these numbers? That's again a hyperparameter optimization. So that's the key I'm going to use all the time the moment you ask me, because we don't know. And all of those will be something that we're going to optimize as we go on. Yeah. I hope this makes sense. And now we're getting in the territory of building slightly bulkier, more heavier models and look into all the things that you have to optimize. So that's why it's not a pure science. If you think building a model is a pure science, it's not. It's more art than science, actually, in my view. Right. So that's why a lot of people who are artists naturally will find a better model to come out, right, by playing out with different things. So that's what the min sample split really means, right? But unless you have that many, I will not split further. Yeah. Question, any? Same. I will tell you in the next class. Just hold on to that thought for now. Yeah. So we tried different settings. Say, go with the 5, go with the 10, go with the 15, go with the 100, right? So you can have a range of things, right? And then it will build that many versions of the model for you. And then you will look into what version of the model is giving you the best performance in terms of the precision and recall, and that is what you're going to choose. Yeah. So you have a yardstick that go and play out. You try all you want to do in terms of these different hyperparameters, the values that we're looking at, but find the one which gives me the best precision or best recall or best F score. And that will be the setting that you're going to use. That's the crux of that in terms of the hyperparameter. Yeah. Okay, so that's the this one. Let's go back to the, and I'm going to talk about one more because there are many different things, but these are the three main ones. So criteria, max depth, min sample split, and then we have the min sample leaf. Who would like to explain? In the end node. So in the leaf node, leaf is the last one. I mean, leaf cannot grow the branches, right? So the leaf is the last one. So in the leaf node, how many minimum members do we require? Right? So that's the end node basically. So if you say each of the end node must have at least 10 species, then it's going to use that criteria to split it further. And you can try out different settings. I mean, you will, in your tree only, you can try out different settings and see what really comes out. But min sample split, min sample leaf, and then you have the weight and other things that you're going to try out. So I'm just going to make it interesting and just go one at a time. So let's go and play with the depth only depth, right? So over here, and that's why I like collab, but somehow because of the slow internet connection, it doesn't necessarily behave very well. So no, there it is. Yeah. So max depth. I mean, I hate typing. So max depth is 3. What do you think the tree is going to do? It will have maximum of 3 levels, not the root node, but 3 levels after that. Max of that. Let's run it. And the easiest way of doing that is I'm just, because it's a small data, I'll just run all. Rather than me going, scrolling, this, that, right? So now you can see it's a different looking tree. Yeah. Only 3 levels it will go to. It may go even less, but it says, okay, you asked me 3. So 1, 2, 3, that's your 3 levels of the tree. If you remember the previous one, it had more levels. Actually, I think it had 5 or 6, if I remember. So now it's just saying 3 levels is what we're looking at. Correct? Yeah.
Here maybe we are terminating with this version or no, on this version because what we are meant and then
Correct. Correct. But you never get the 100% separation also, right? In reality, that's like, I mean, you wouldn't say like, I want to build a model which is 100% accurate for the defaulter and non-defaulter. There's always going to be some gray area that something is misclassified. And that's the whole rationale of having the confusion matrix, right? Never going to be a perfect model. So this is also not going to be a perfect model. Overfitting, exactly right. So even if you do it and the tree is giving you the best separation, and the reality is just going to fall apart, right? So it's better not to overfit and all of that, right? Now let's add one more criteria over here. So now we will say min sample leave, which Tejashwi, you answered correctly. So what do you think will it do now? So min sample leave. I'm gonna say min sample leave is 25. What do you think this will be? Each of the terminal nodes will have a minimum of 25. So it won't be splitting further. I mean, even though it can do a further purification by saying, because you asked me to have at least 25 members, I will stop here. So it will be further mixed up. Impurity will be higher because 25 flowers may not necessarily be the purest. So let's go ahead and run it. Oops, sorry, I just did the wrong one. Let it finish. Run all. Okay. Now you can see the terminal nodes, each of the terminal nodes. So this is a terminal node, 50 flowers. This is a terminal node, 46 flowers. This is the terminal node, 25 flowers. This is a terminal node, 29 flowers. Correct. So now you can see each of the terminal node has a minimum of 25 flowers that you wanted it to have. It can have more. It can have more. Why? You can answer that question. No, that's a good observation. Why it's not splitting further? This purple, why is it not getting split further? It's 45 and 1. So how can you separate the classes? 1 can be the only one in a different bucket, and 45 can be the other one. But the moment 1 is there, it says, no, I'm violating that criteria of 25. So I'm not going to split further. Right? So that's how basically it thinks. Similarly, over here, it can, 25. I mean, of course, it's not going to split, but here that could have split further, but there's nothing to split. I'm the purest node. So it will stop. It will stop when the entropy of the genie comes to 0. Doesn't matter how many levels or depths you specified, it won't go further because it says there's nothing to split. Yeah. Similarly, you can play with the other settings. Now, this is the time for you to finish before your lunch break. You're going to do exactly the same thing on Titanic data, but you're going to fit this model on the train data, and then you will do exactly the same thing like a classification, confusion matrix, everything on the test data. So it's not any different from any other classifier. And I'm going to point you to the blog as well. So I just help you with the visualization, but I will ask you to create this entire output for your Titanic data. And you can follow this blog, how I have done it for a different data, of course, not a Titanic data. But I would like to see what precision and recall you're getting for your Titanic. What metrics we're going to use for the evaluation of a decision tree? Correct. And if it is a regression? Exactly right. So if it is a classification, then you're going to use a classification set of metrics. If it is a regression, then you're going to use a mean square error, root mean square error, all the things that we're familiar with, right? So not this one, but I'll tell you the article that you can follow along to replicate the output for your Titanic. So this was the Iris one. I think I'm building on a telco data, some like churn data, right? So don't replicate on the churn data, but you can get the motivation on how we are doing that, right? So exactly the same flow that you followed for a logistic regression. The only thing you want to change over here is this. So import decision tree classifier. Criteria you can choose, max depth you can choose, min sample. I'll let you play with this, right? Then you're gonna fit your data on the train X and train Y, right? Then you're gonna do the prediction on the test X. and you will plot the tree using the same thing as we have done earlier. So you will basically, you can ignore this one. I think it's a different criteria, but use the same one as the CLF that we've used earlier on, which is right over here. You will visualize your tree accordingly, according to this, like the classification that you're going to generate. Right, so you have, instead of saying the data, you will do the X train, Y train, and that will basically the classification, and then you will replicate exactly the same line like we have done over here, but instead of using the iris, it will be Titanic dot feature names, Titanic T, huh? Come, okay, T, okay, so T again, second T, अच्छा, इतना इतना और कम, हाँ. Yeah, so you will use Titanic.features name, Titanic.target, and all of that. And let's see what is the best precision and recall you are able to get. So over to you before lunch break. 1:30 or 2, what time you want to go for lunch? 1:30? So I think you can wrap it up quickly on the Titanic data, yeah? Folks online, we're gonna regenerate this output on the Titanic. We will create the entire classification report as I have in my article, which is the article number 32. But on the Titanic data, right? So let's see what is the best precision and recall anyone is able to get. And then we will come and have one of you present and we will try to interpret that, right? So I will shut up now and then give the opportunity to for you folks to work. So sweet for me. Very sweet. Somebody should tell her that sweet can be put. No, sweet can be put later on also, right? I mean, why to put the sweet? I mean, while making the tea. I mean, so just give the flexibility to the people to yeah, prepare without sugar and then let the people decide how much sugar they want to have. I generally don't drink with the sugar. I mean, even though I'm not diabetic or anything, but I have got used to not drinking without the sugar. So it just like makes my mouth very sticky with the sugar and everything. Yeah. Yeah. Anyone online has any question, folks? I believe you are clear on the assignment, and it's not an assignment, but the class activity. Let's see what is the best you are able to get. And I have the output over here, but I'm not going to share that because this is for you to figure out. Yeah. So if you have already filed new notebook, yeah, yeah, I will open a file, open notebook, and I will just search for tree, and you'll see I have a decision tree for Titanic, and I'll show you how that tree looks like. And interpretation is going to be quite easy and straightforward, right? So I'll just tell you so that you can benchmark what I have done. By the way, you have to do entire missing values, everything like a regular logistic regression. So I suggest that you work with the same file, but just make the changes towards the end, right? So in my case, this is how the tree looks like. So gender came out to be the top criteria, fair, all of that, right? Came out to be those criteria. And I'm not going to do the cross validation today. And let's see what is the precision and recall that we got. Confusion matrix. I don't think I've generated the matrix, but like the accuracy score came out to be 78%, right? So if I run the code here, I can tell you the precision and recall as well for this data. And then your assignment will be do the same thing for the loan data later on in the second half. Exactly the same thing for the, and including the random forests, compare logistic regression, random forest, decision tree, which one gives you the best results. So it is here actually. So the recall came out to be 55% for the Titanic data. So let's see how much you are able to get. I'll be back in a minute. Yeah. If you're confused, you can scroll up and down. Yeah. Yeah. Somebody's Resh is the only one going solo. Jupiter, okay, okay, got it, yeah. 5 now.
Oh my God. But that's something that people ask, we have to ask about.
How are we doing? All good? Yeah? Jupiter is working. Okay, awesome. What was the update? But he already installed, no? Okay, okay. Awesome.
Hello, sir. Hello.
Yeah.
Manjunath here.
Yeah, Manjunath.
Yeah, so I'm done with it. Actually, I was about to leave in 20 minutes. Probably second half I'll not be able to attend.
Okay.
So I got results as accuracy is around 79.88.
Mm-hmm.
And precision and AOC is 76 and precision recall is like 0.81, 0.90 for zero class.
Okay.
And for one class it's 0.77 and 0.62.
0.62. Okay. Yeah, I think pretty decent results compared to what I have as of now. So good one. And I know, I mean,
Okay.
Manjunath, you have some sick child at home, so feel free to take time off, right? And you can submit the assignment even later in the week as well.
Yeah, by tomorrow I'll try to submit, sir. I'll
Oh,
go through video
sounds
and then see what can be done. I'll be leaving for the day.
okay. Take care.
Yeah. Okay.
Thank
Thank
you.
you.
Sir, there is one question.
Yeah.
Sir, categorical variables we can treat by dummy coding. How do we treat booleans?
Boolean is the same way. I mean, which one is a Boolean for you?
Adult male and alone.
Oh, we're not doing on the loan data yet. We are doing on the Titanic actually.
Oh, sir.
Yeah, we are doing on the Titanic as of now.
No, Titanic only. It is there, no? Two variables.
What is the one?
One
Maybe you
is,
can show your screen. We can take a look.
wait a minute, sir.
If you share your screen, then we can take a look. Yeah.
1 second, sir.
Yeah.
Can you see the screen, sir?
Yeah.
Here, adult male and alone are Boolean.
You need to drop them. Remember the same thing that we've done last time around.
Okay.
So just go back to the logistic regression. We dropped some of those variables because they are redundant, right? So the gender or the sex itself is sufficient.
Okay. Yes. Right, sir. Thank you.
Same thing. And exactly the same thing, just fitting will be different on the decision tree part. Yeah.
Okay.
Perfect. You're good to go, huh?
82 actually.
82?
It's for 80.
For the class 0 or 1? What is for 1?
I mean, that is
Do the entire class in question. And if you can come and present your work, either one of the team. Ganesh, you're good to go? No. Rashmi? Take it and those not survive. One is survive. What is one? For getting a report study. And how much was it for the logistics? If you remember?
one of the one. But here they are giving 72 for one. There we had 85 for the because we had only 89. I will give
And did you do any pruning in the tree? Pruning.
yeah, 3 levels.
Try without pruning. What is the value?
Categorical
Sorry,
Strings, strings, strings.
What? It not work. Estimate won't work without the iniquity. For like I mean, just like a logistic regression flow, completely the same flow.
Yes, no, I thought might be without that.
Yeah, you could do the dummy coding of those things. Yeah. Outliers can be a little bit more lenient on, but dummy coding effective must. Missing value also required. Yeah, because SQL does not tolerate the missing value. Missing value will be required. Dummy coding will be required. Outlier, you know. And to try without pruning it, that's what we really get out. It will be difficult for you to visualize it.
Yeah, we saw that.
It will be difficult for you to visualize, but then you will get a like high water mark and think of what is the best you can get. Recall. 100% right. On that test, on the trading, recall the test. You can set it up. Just like the logistic regression. Just like the logistic regression, you separate out the trading and the test, and then you take this. Oh, so they just be generated on the entire data. Meaning that won't be bad. Fit the model on the train data, generate the statistics on the test data.
Okay. नहीं होगा फीचर में
Next door problem. Yeah. With the names.
and class में
Oh, it's come down to noise simulation. And this is the like complete tree, not
correct.
Okay. Hey, what a pleasant surprise. Yeah.
wanted to say I'm
Yeah.
happy and please
Folks, can we just pay attention? Yeah.
No, no, we came to just to say-
Oh, just to say hi to
Yeah,
me?
just to-
Thank you. Yeah.
They were only telling me. See, Dr. Sinha, I don't have to.
Yeah.
They are part of it. This is the program for Sony.
Huh.
For RPA thing, then the non,
They came here online only. Online.
Monday to Friday.
Very nice.
You know that?
For the
Project Covid is from NASA. So immediately everybody will up.
Do it for AI.
Project management from race.
That's what I was thinking.
We want to popularize basics from these people studies in the market. We want to keep this. We already have it.
In the Sony using the project.
You are a poker face here. I want to do a last one.
You're not very expressive.
Yeah.
Last like.
It's my fault.
Only when I get it. No, but fluid project fluid is like a different paper. Okay, nice. That's good, yeah. Of course, this is a network course always. Yeah.
So what do you say?
We have this trademark both there was the driving she and
So what we did is the business understanding is there. But what is being collected, what exactly is the we have created two different things before it gets into defined for it start building the model. So that is collaboration. Now under collaborate, we have multiple stakeholders. We have a CEO, so we had our own stakeholders.
Okay. Got it. That's good. That's good. You're putting them like in the nature scenario, yeah.
so it is the approach not from a data set. And you borrow a lot of the design.
Okay.
For an art marketing, they are saying that where is the empathy towards the user? That is
And the
empathy.
users are multiple.
You haven't shared any doc on this, right? With me in terms of the recorded version.
We have a nice benzene ring as the thing that each so I thought you were already
I mean, I've heard the term, but I mean, I didn't know like what all it entails. What are
not this project, we are saying that qualifies the project. Not everything may be a AI project. Not everything might be answered very well.
Yeah.
And we are also thinking of developing a fluid scale. Tomorrow we will go to school and like prepare like a checkbox thing that these are the 6 stages where I use. If they get a score of let's say 40%, which is not good enough. On the full score, we increase the score, let's say they go 60, 70. You're there.
We can do a pre and post it, before going to the section and then post the section.
We have collaborate with multiple stakeholders. There are some frameworks. It's the market. That essentially will automate.
Nice case study we took the ice cream selling in Mandalore, Korea. Goa. So, what should they eat actually? Usually we put sauce and actually they see what about the ROI that you got.
The business impact, yes, what we're able to present. Because the metric may have moved only by 2%, but the business impact is related to CX for the business.
I think we want everybody to start contributing.
If you share the doc, I will give you my thoughts. To be honest, if I wouldn't say like, it's all good and all that, share. Yeah.
The plan is now. So one more week of say the entire collaboration.
Yeah, of course, we need to get the buy-in from the stakeholders. So take it forward.
6 stages, CDD.
Sounds good. I think some of these frameworks are great for they've done their life in mind.
But I think it's a like something like this. The course that we see, the diagram now looks good.
push it on the LinkedIn as well. I think that will be like you can take it. Multiple brainstorming sessions. Yeah. They will be like it can find a good we can find stakeholders. We can find.
What we can do is that sample for campaign management. Don't put too much. But that will put in
So I am doing something similar, but for deep dive for within my team members. How do you know people in deep dive versus tactical, themes or things? How to manage it, how the and this is a good for who are doing the data science project, how their project stands. And you can actually create a tool around it, and you can upload your presentation and all things. Exactly, you create presentations. Where does your organization stand? I'm not the organization. Anybody can upload any presentation. Basically, you have a section
and there is a sample of and then start as you fill, you can do some kind of a text analytics and keep on adding.
And it should be standalone. So I don't need, for example, she wants to know how the project scope, right? She doesn't need to be there, and she should not be there. Only her presentation and the writer saying, yeah, you upload that and the video scope. So that will be the scalability that we will bring in.
Yeah, we also give some when you talk to
And you will have, almost of, material also that you can.
all our students projects you don't need type of vibe or family. That's the first level.
It will like give you section by school. So you can break it down in 5 It can be. I know not everything can be automated, but I mean, like the writing will be on the spelling, right? Other things. I mean, there are many tools. Then you can start to incorporate several projects.
Let's say how many actually say actually what is the cost of the debt? And say that 80% of it ask to say $5 that's a big deal. It is right way. Now we pay run this and then I think because people are so much of our own participants' time and energy add all these more extra they are creating.
Project evaluation. When I'm doing the academics, the time, corporate, what type of skills and they could be different. It means like just a very right?
source should come out. Why?
Some other people like, I mean, I'm giving you this plus, 1 hour of time with the metro. But other could be unlimited for the I think this was. Any areas I'm telling you, the image that I said, you talk in here, these actions. Yeah. The area and I mean, like the amount of money that is already in the market right now, this much cash. But you have to show that you are having
We also can.
so many people that they don't like the card. If you have some document which you want lunch I brought something. Are you going?
We have not ordered anything for them. Shall I take it?
I brought something because I thought just grab something.
Yes, you're having lunch or how?
You have the lunch rescue.
Yeah.
The lunch buddy.
process is right.
Okay. I'm gonna eat here something folks. I need to catch up on something so you can carry on. Yeah? Once you come back, then we'll go through your presentation or I mean, what you've done. Not presentation, but what you've been doing. Yeah. I'll be happy to sit down with you now. You can give me a call later on. Oh, I like the mask, man. This is quite good actually. Is it cotton or like fabric?
Cotton
Cotton.
provided by company.
Achha. It's quite big.
तो हमें भी लेके आओ ना.
Share your mask. Share it, boy.
Yeah. And share the virus.
Initially, they were produced inside our office, some other plant. Airbags, basically, right?
Yeah.
So instead of bag, they